Hey guys, so we're going to take a look at how to use our periodic table to determine the structure of an atom based on the information that we're given. So our end result is going to be pretty similar to what we did last week with the simulation, where we get a picture of what the atom looks like, just a difference in how we get the information. So the first example that we're going to look at is carbon. So here's carbon right here on the periodic table. It is element number 6. We can see that here's the C for carbon, the name carbon, and then underneath here is our mass number, okay? So what do those pieces of information tell us, and how can we use them to create our atom? So we know that carbon has an atomic number of 6, okay? If we think back to last week, that atomic number, in addition to telling us that it's carbon, is also going to tell us that it has 6 protons. Okay, and for now, we said if it has 6 protons, it's also going to have 6 electrons, because we're only going to look at neutral atoms. We'll get to a point where this is not the case, but for right now, our protons are going to equal our electrons. Okay. The other thing that we can tell from this periodic square is that it has a mass number of 12. It's actually 12.011, but we round to the nearest whole number when we're using the periodic table. So we're going to use that this is the mass of 12. So if we think back to last week, we found that there are 2 things that make up the mass of an atom. It's protons and it's neutrons. So if we know that carbon has 6 protons and it has a mass of 12, we can use those 2 numbers to figure out how many neutrons it has as well. So we're going to take 12, we'll subtract 6. That'll give us that it has 6 neutrons. Okay. So from there, we can use these pieces of information to actually draw our carbon, okay? So we know that protons and neutrons go in the nucleus. So I'm going to draw my nucleus here, and just to make it a little easier to read, I'm going to label this as 6p and 6n. I could draw them all out, but it gets pretty hard they're super small and it gets hard to tell what they are. So I'm going to then place the electrons around the outside of the atom the same way they were in the simulation. We call this a Bohr model, okay? And there are a couple of rules to making a Bohr model. This first ring outside of the nucleus can hold 2 electrons. The second ring outside of the nucleus can hold 8 electrons. The third ring outside of the nucleus can also hold 8 electrons. So now when I'm dealing with carbon, I only need to find a place for 6 of those electrons. So here's 1, 2, 3, 4, 5, 6. Okay, so remember, I could have added up to 8 here, and I could have added up to 8 here, but I didn't need to add that many. So I just needed 6 electrons, and there they are. They're all in their right places, and I have my carbon atom here. Okay, we're going to look at one more example. We'll look at magnesium. So magnesium's over here on the periodic table. It has an atomic number of 12. And it has a mass number of 24. Okay, its symbol is Mg. Here's where it says magnesium. So what can I get from these 2 pieces of information? Well, from an atomic number of 12, I can determine that it has 12 protons and that it has 12 electrons. From a mass number of 24, I can determine 24 minus 12 protons gives me 12 neutrons. Just a heads up, these two numbers won't always be equal, okay? For example, if we look at sodium, the one right before magnesium, it has a mass of 23, but 11 protons. So 23 minus 11 means it would have 12 neutrons. So you always have to do that step of subtracting. You can't just assume that the protons and neutrons are equal. Okay, so then we can draw our atom. Here's the nucleus. It's going to contain 12 protons and 12 neutrons. Then we can start filling our energy levels outside for our electrons. So if we remember, it's 2 can go in the first, 8 can go in the second, 8 can go in the third. So here are 1, 2. I need to get up to 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there we have our magnesium atom.